So hello everyone, good morning, good afternoon, good evening, wherever you are. I'm Dzmitry Kniahin, a session chair. I'm economist and statistician at the International Trade Center, a joint agency of the WTO and the UNCTAD, and a PhD candidate in the University of Geneva. So I work on international trade and specifically right now on market access and trade barriers in supply chains. So I'm notably constructing MapMap database with other colleagues. The session host is Dr. Erwin Corong, a research economist at the GTAP, Purdue University, who has provided many contributions to GTAP and practical applications, policy papers over the last almost 2 decades. And he holds a PhD in economics from Monash University, Australia. Our session topic is supply chains, and it will consist of 4 paper contributions, assessing economic impact and measurement issues in international supply chains. So we will have 4 speakers with different backgrounds. So it will be Barbe, Candise, Thierry Kinkpe, and Onur Biyik in this order. I will introduce them before the presentation. In terms of the rules, so the rules are the following. Everyone please remain muted during the presentation and do not interrupt. The presentation time is limited to 20 minutes, and the session host, Erwin, will signal when there are 2 minutes left. After that, there will be a 10-minute discussion time with questions and answers from the audience. Please do not hesitate to type your questions into the chat directly at any time, or raise a virtual hand after the presentation to ask your question or comment. In the end, we will summarize the discussion on the presentation. Between presentations, there will be 2-minute pause to allow the next presenter to share the screen. And during this time, I will introduce the presenter. After the session, there will be a wrap-up of 4 minutes. And after that, we will adjourn. With this, if there are no further questions or comments, I would like to start the first presentation by Dr. Barbe. So he's a consultant at the World Bank, and he held economic positions at USITC and the Council of Economic Advisors for the President. He holds a PhD in economics from Rice University, Texas. And his paper is on the economic impact of local content requirements in South Africa. So please, you can share your screen.
Yeah, thank you so much, Dzmitry. Let me see if I can share my screen and see if this works. All right, does everything look good?
Yes.
Okay, perfect. All right, so thank you all for joining me for my presentation. I'd like to talk about some work I've been doing looking at the economic impact of local content requirements in South Africa. So I'm a consultant at the World Bank, but this presentation here will just be done in my personal, not official capacity. Okay, so here's just an overall outline of this presentation. First, I'm going to give you some background on what local content requirements are and exactly what South Africa has been thinking about them. So to briefly summarize, local content requirements are a policy tool that many countries use to try to promote their domestic economy through increasing domestic input usage. And in particular, South Africa has stated a goal of reducing their non-fuel imports by 20% by 2025, and using local content requirements as one of the methods to achieve this goal. The overall research question I'm going to try to look at is to compare different methods of accomplishing this goal for South Africa. So, for example, if they, instead of using local content requirements, used more traditional methods like tariffs, and using the Envisage CGE model to see what the impacts of either of those two methods are. And the main methodological innovation I have to do is to figure out a way to model local content requirements in a CGE model. But when you do that, what I find is that reducing your imports via local content requirements actually has a more negative impact on GDP than reducing it via tariffs would. So if you reduce it via local content requirements, GDP falls by 1.3%, but tariffs would only cause a 1.2% fall. And so my general finding is that local content requirements hide their costs better than tariffs, but have larger costs than tariffs do. And so with that, let me get into it by starting with the background information. What are these local content requirements and what is South Africa doing? So in October 2020, in the midst of COVID, South Africa announced their COVID economic recovery plan. Now it had many different goals, only one of which is really relevant here, and it's to reduce South Africa's non-oil import bill by 20% over the next 5 years. Now, this is the type of policy that I feel is maybe a little bit of a stretch goal or euphemistic or something, and that maybe won't necessarily be accomplished, but does still direct and affect policy, even if they don't reach the full goal. So in response to this policy, South Africa's Department of Trade, Industry and Competition has implemented and is implementing several plans for various industries for them to reduce imports and increase domestic input usage. And these do include strengthening or creating new local content requirements. So for example, currently in South Africa, retail and wholesale buyers of sugar are required to get 80% of their sugar from domestic sources, and that's going to increase to 95% under these new plans. So what are these local content requirements in general? Well, they refer to a pretty wide variety of different policies, but I think the most relevant one in terms of trade and trade policy are restrictions on input sourcing. So firms may be required to source a shortened share of their inputs from local sources. So for example, you might require domestic auto manufacturers to buy 40% of their auto parts from domestic parts manufacturers in order for the vehicles that they produce. Something like that is like, I think like a pretty prototypical local content requirement. But there are other ones as well. So for example, maybe you might require a company to locate their production domestically or to only use or to build up certain types of infrastructure in the country. These laws often, but not always, apply only to firms wishing to sell their products to the government, but may also apply to an entire industry, regardless of who is being sold to, as in the sugar requirements discussed earlier. So these local content requirements can be worse than tariffs because although, I mean, tariffs very obviously impose trade barriers and trade inefficiencies, but local content requirements are especially inefficient because they only target intermediate inputs, not final goods. So what this means is that they increase production costs for the domestic producers. So say in a previous example, automobiles, as they have to use more expensive domestic parts rather than being able to source to cheaper imported parts. So what this means is that it leads to lower exports and increased imports in the non-protected sectors. So if you protect the auto parts sector, that's going to hurt the auto assembly sector, right? And so this can actually reduce local production when these downstream impacts are considered. And it also incentivizes consumers to just import the final goods. Like, well, if our domestic auto manufacturing is going to be more expensive, we can just like import the final automobile from abroad and not have to deal with that. It becomes relatively more attractive to import from abroad. Local content requirements are relatively common in South Africa. So especially for government procurement, many of which require 100% of inputs to be locally sourced for certain pieces of equipment. So one example of this is the fire truck industry in South Africa. So if a firm wishes to sell fire trucks to South Africa's government, there's a requirement that the superstructure, basically not like the wheels and stuff, like the main body of the truck, must be 100% produced in South Africa. Unfortunately, given like the infrequency of fire truck purchases by South African government, it's not really cost effective for any firm to set up its capabilities to produce the superstructure of the fire trucks. So as a result, no local assemblers of fire trucks can meet the local content requirements that South Africa imposes on them. Okay, so given these issues with local content requirements, the question I'm going to try to answer is, what is the impact of reducing South Africa's non-fuel imports by 20% via these local content requirements, as opposed to more traditional and more legible methods like tariffs? So a tariff is very obviously, I think, well known, going to have negative impacts on other sectors of the economy and on trade, but it's kind of like clear what impacts it would have, whereas the impacts of local content requirements, I think, are a lot more subtle. All right. And so let me take you through my methodology for answering that question. So I'm going to use the Envisage computable general equilibrium model. It's a fairly standard computable general equilibrium model. So if you're familiar with the GTAP model, it's pretty similar, but with a few improvements. So it's multi-region, multi-sector, perfect competition, constant returns to scale. If you're familiar with the GTAP model, one of the differences with Envisage is that it's a dynamic model with many time periods and adjusting capital supply. But also, like the GTAP model, has explicit modeling of international trade and regional labor supply, but a little bit better modeling of the regional labor supply than the standard GTAP model. But again, like the standard GTAP model, it's used for forecasting the impact of policies with large international components. So at the World Bank, it's used a lot for estimating the impact of climate change policies, trade agreements, tariffs, that sort of thing. Okay, so I'm going to use this model to look at three different scenarios. So remember, the overall goal is to reduce non-petroleum imports by 20%. And so I'm going to use the Envisage model to estimate the impact of two methods of achieving that goal: local content requirements or tariffs. And so that's done with three scenarios. So in the first scenario, it's just the baseline scenario, no change in policy from prior to the implementation of the COVID reconstruction plan. Things just go as they are. And then there are two policy scenarios. One is the tariff scenario. So, all right, I'm going to say that South Africa increases tariffs on imports of all non-fossil fuel commodities. And the tariff rate increase is going to be chosen such that you hit that 20% import reduction goal. And in the third scenario, we're going to kind of do the same thing, but with local content requirements. So South Africa is going to impose local content requirements on all sectors of its economy, mandating that they increase their share of non-fossil fuel material inputs that come from domestic sources. And the mandated increase in share is going to be such that they hit that 20% target. Okay, so I'll go into detail on that third scenario because that needs some explanation. But first, to create an apples to apples scenarios in both the, as I said before, both the local content requirement and tariff scenario, the strength of the measures I'm imposing is chosen so that they both hit exactly that 20% decrease in non-fuel imports. Okay, so I think maybe it doesn't need much explanation to say that I increase tariffs on all sectors by such an amount that imports decline by 20%. So baseline seems straightforward, and that tariff scenario seems straightforward. What does it actually mean to have this scenario where I impose local content requirements? And so I'm going to model local content requirements as a binding quantity constraint on the firm's cost function. So this has two impacts. One, it's going to, think back to your microeconomic theory course. So when you have some sort of cost minimization problem, which has some constraint imposed on it, that like changes the form of the Lagrangian, and now you have to worry about the difference between like the price and the shadow price, depending on whether that constraint is binding or not. And I'm assuming that these local content requirements that are being imposed are binding constraints that actually cause domestic input usage to increase. And so what that means is that in terms of like shadow prices, that's increasing the shadow price of imported inputs used by each firm, and it's decreasing the shadow price of domestic inputs used by each activity. So if you normally use, I don't know, 80% domestic inputs and 20% imported, and now you have to go to 90% instead of 80%, it's basically decreasing the shadow price of your domestic inputs to cause you to increase your usage of them from 80% to 90%. So in terms of modeling this on like a single firm in the CGE model, this is actually equivalent to imposing a tax on that firm's usage of imported inputs. So a tax increases the shadow price, and then also imposing a subsidy on that firm's usage of domestic inputs. So a subsidy decreases the shadow price of the domestic inputs. But because we only want to change the shadow prices, not the real prices, the tax and subsidy rates must be chosen such that they're revenue neutral, so that the new basket is on the old ISO profit line. There's no change in government revenue. There's no revenue transfer to the firm or anything like that. So it's chosen to be revenue neutral. And so if you think about that impact on one industry, then if you wanted to impose local content requirements across the entire industry, you should like repeat that process for all the activities. Like in industries are called activities in the Envisage model, since there's one representative firm for each industry. And different industries are going to have different tax or subsidy rates, because it's going to require different changes in the shadow prices for different ones, depending on how much inputs they already use in order to hit that 20% reduction target. But there is the tax and subsidy changes are going to have to be revenue neutral on a per industry basis. And since it's revenue neutral for all industries, when you add it up over, since it's revenue neutral for each industry, when you then add it up over all industries, it's still going to be revenue neutral. So for simplicity, I choose to give all industries the same increase in like the phantom tax rate, but this is going to lead to different increases in the subsidy rate in order to achieve revenue neutrality. So if, for example, if a firm has a lot of usage of imported inputs, then they're going to have to end up with a pretty big subsidy to make it revenue neutral with that tax rate. So this is a little bit confusing. I had a pause to ask for questions. I guess maybe we're not supposed to ask for questions in the middle of the presentation. But if there are any burning ones, I can take questions for a second. Okay, that whole shadow tax thing may have been or shadow price thing may have been a little bit confusing. So if you have the questions afterwards, I'm happy to answer them as well. Then let me move on to results. So both policies can achieve that 20% reduction in non-fuel imports, but the local content requirements are a slightly more costly way of doing so. And then, as you might expect, kind of like with any CG modeling of a trade policy, it benefits some sectors and harms others. And basically, the protected sectors benefit, the downstream sectors of the protected sectors are harmed. So if your sector faces a lot of import competition from foreign producers, and it's an intermediate input in other sectors, then it's going to benefit. But it's going to harm sectors that use lots of intermediate inputs or that export their product and thus are really sensitive to the price increases this causes in their competition outside of South Africa. Okay. So this chart is going to show the economic impacts on South Africa in aggregate. So I have three different parts here, the impact on GDP, imports, and exports. And so the blue bar is the impact from the tariff scenario relative to the baseline, and the orange bar is the impact on the localization scenario. And they seem pretty similar. Both policies achieved a 20% reduction in non-fuel imports. Since it's 20% reduction in non-fuel imports, total imports don't change by 20%, but they change by about 16% in both scenarios. And if you look at that leftmost set of results for GDP, localization has larger negative impacts than tariffs. And this is basically, so you can almost think of localization as a tariff where the revenue is spent on being subsidized domestic production rather than going to the government. So it's going to have some additional efficiency costs and not have the same gains that you would get if it was just used to increase government revenues, and then in this model refunded to the households as a lump sum transfer. So overall, they're pretty similar impacts, but slightly more negative in the localization scenario. But then if we look by specific sector, it's kind of like as I described earlier and as you might expect. So it tends to help sectors that face a lot of import competition. So for example, light manufacturing, a lot of its inputs are used by other sectors, and it also faces a lot of competition from foreign inputs. It also doesn't export very much of its production. So light manufacturing is one of the big winners of this policy. Another winner is chemicals, since it also doesn't export very much. It has some amount of usage by other industries. By contrast, if the opposite of those are true, a sector is harmed. So sectors that use light manufacturing as an input are harmed. So especially energy-intensive manufacturing is a major usage of light manufacturing inputs, and so it's harmed. Or if a sector's inputs are, or if a sector is like its output is exported a lot. So for example, fossil fuels, there's a lot of exports of that. So it is one of the main sectors that is harmed. Okay. So then if we, I'll go through those, but if we first look at imports. So this graph on the right, it shows that technically it shows the sector's absolute change in imports divided by the baseline grand total imports of all sectors expressed as a percentage. So that might be a little confusing. I guess the way to think about this is it's like the absolute change in imports in terms of dollars. So if you like take those bars and just like add them up for all the sectors, it'll like add up to the grand total. So what this is saying is like in grand total, you know, imports are reducing by about 16%. And of that 16% decrease in imports, about 10% is due to the increase in imports in light manufacturing. That's what that, you know, minus 10 right by this means. This means about 10 percentage points of the 16 percentage point drop is due to light manufacturing. So it's really the drop in imports is driven by light manufacturing, but you do also see a drop in imports in pretty much almost all sectors, especially chemical, rubbers, and plastics. The one exception is fossil fuels, because again, we're not imposing any restrictions on fossil fuel imports in either scenarios.
2 minutes, Andre.
Oh, okay, I'll move up and be quick. Then if you look at gross output, you see kind of like the reverse effect. So light manufacturing and chemicals are kind of like the big winners here and have a big increase in their gross output, whereas energy and intensive manufacturing and fossil fuels, as I said before, were kind of the losers and had a decrease in output. And as you might expect, you know, as we're talking about increased usage of domestic output for domestic inputs. So these graphs here show the output for domestic use by sector. And so chemicals and light manufacturing are now producing, you know, a good bit more output for use in other sectors. So that's exactly what you would expect if you impose local content requirements that required you to use more of those inputs. And then finally, we actually do see it reduces exports for fossil fuels and energy intensive manufacturing, as discussed before, but also light manufacturing, as it's less competitive in the rest of the world, but also it just has more attractive markets relatively domestically. Okay, then to let me conclude. So South Africa and many other countries mandate local content requirements as a way to promote their domestic economy. We use the Envisage CG model to show that this doesn't really work. Local content requirements have larger costs than tariffs do. They just kind of like hide them in an illegible manner. Some final thoughts. I think this conclusion isn't too surprising, but the value of CG is the power of putting numbers on the intuitive arguments economists make. So I think if we tell policymakers local content requirements are inefficient, they kind of like don't listen. But when you can show that they reduce GDP by an amount, it's much more persuasive not to impose these measures. Then some questions for the audience in case they might find it helpful. What do you think about the way I model local content requirements? What parts of the model or analysis were you less confident in? And if there are any questions, local content requirements you have that may remain unanswered. And then finally, if you're unconvinced by this, do you know of any arguments the pro local content requirement side would make that I am missing? And thank you for your attention. That concludes my presentation.
Thank you. Thank you, Andre. It was a very interesting presentation, a very interesting topic, and it connects with rules of origin, in fact, to some extent, which is a big topic in international trade. So I would like to open the floor to questions, comments from the people. Yes, please, Krishna.
Hi, thanks. Andre, it's an excellent presentation. In fact, I'm kind of working on LCR my own, presenting tomorrow a little bit. So yeah, it's nice to see one such as yours. And I really like your approach. I do have one question though. Does the prices changes, right? Because of your playing with the shadow prices, does the prices of, for example, light manufacturing becomes more expensive now, right? And the consumers of that good then becomes worse off. Did you do anything about this welfare stuff? And secondly, I kind of caught what you're saying about shifting tax, right? So this is basically shifting the gain from the government from income tax, if we use tariff, to the industries in the form of the subsidy that you're toying with the model, right? That's why you see that light manufacturing gain much more, and then probably because of the subsidy in your model, if I caught it correctly. My question is, in South Africa, does light manufacturing actually provide a lot of income taxes compared to other industries? If that's the case, then in terms of income, the income tax from the light manufacturing might be able to close the gap from the government perspective, right? For example, in other countries, some industries really lots of informal pay very little tax and stuff like that. So would this way of thinking kind of make sense to you, like the different income taxes paid by different industries? Thanks.
Yeah, that's great questions, and thank you. I'm glad to see other people working on local content requirements. Yeah, if you want to like send me like a link or something to your presentation or your paper afterwards, I would appreciate it because I'm really interested in like reading it and attending tomorrow as well. To answer, I guess, your first question about the welfare impacts, let me see if I can share my screen. Let's see. Yeah, I apologize. This was, I think this is the paper, so it was not in the presentation, but in the paper, I do discuss the impacts of the different policies on welfare. And so the local content requirements actually reduce welfare by 0.7%, while tariffs actually have no impact on welfare. And it's basically the reason for the tariffs is basically there's two things going on. So there's an increase in government revenue that's kind of like returned to the households as like a lump sum transfer. And it also adds some inefficiency, from production. But part of the burden of that tax is actually borne by the foreign supplier. And so it actually ends up kind of like being a wash. So where the part of the tariff borne by the foreign supplier is about equal to the domestic like X efficiency loss. And so there's kind of like a no net impact on income from tariffs. But you kind of like don't get that income gain from localization policy. So it actually has a pretty big negative impact on income. And I guess the difference then again with the localization policy compared to other policies in terms of income, I think so it's actually the model does have basically taxes on different sectors. I don't exactly know how it's set up. I assume it includes, I'm not exactly sure how it works out in terms of income tax. I know there is some variation between sectors and exactly how they're taxed. I don't know how much exact detail that was put on like for South Africa specifically. And I'm afraid I also do not know how much tax rates are for South Africa's light manufacturing versus other sectors of the economy. So I guess in principle, it could be the case that in a more detailed model that government tax revenue would increase. I didn't look at government tax revenue specifically, but with national income going down and GDP going down as well, I'd be kind of surprised if, so it's definitely not going to increase income relative to tariffs, right? Because that's just going to generate more income. And I'd be kind of surprised if it increased government income relative to baseline as well, because both income and GDP are going down. Unless local, the light manufacturing sector is taxed at like double or triple the rate of the rest of the economy. I'd kind of like expect total government revenues to go down, but I'd not explicitly look at that.
We have 2 minutes to go before we need to transition, but
yeah. Can I ask a couple of questions? So first of all, I would like, in your perspective, this result, does it also hold for other countries, or it's only specific to South Africa? If you think Nigeria, Ghana, Russia, they would face similar outcome. And also, I find the strategy of reducing imports explicitly quite strange. Usually, countries talk about reducing trade deficit. So it means there is an implication that they hope exports will increase. Because if imports decrease and then exports decrease, then it's not really a successful strategy to sell to the public.
Yeah. I guess for there's been some research on, I think it was actually a Russian local content requirements that looks at things a little bit differently. So they didn't use my methodology of importing, like putting in the quantity restraints, but they actually did found similar results of local content requirements being pretty bad. I guess I would expect similar results to apply in other countries. None of this particular impacts in South Africa really felt South Africa specific. They felt like pretty general, just, if you protect an industry, that industry benefits, but the downstream industries are hurt. So I would expect the results to be in other countries, but I haven't looked at it explicitly. For the second one, yeah, I think these things usually are discussed in terms of trade deficits rather than reductions in imports. I think that's true.
Okay, thank you. We can wrap up. I think your paper is also interesting in the context of IFCFTA, because we know that South Africa is going to dismantle tariffs with the rest of Africa. So it means it will have to hike really up the tariffs on the rest of the world. And and it might create issues with the WTO. So I think this LCR can be a sneaky way to keep the objectives. And as you show, it might be even less efficient than the tariff way. So I think your paper is very, not only like technically very interesting, but also in terms of policy implications, it's very important.
Wonderful. Thank you so much for the kind words, Dzmitry.
So we would like to move to the next presentation. So the second speaker is Candise Henry, a research economist at RTI International, which she specializes in energy research and climate change. RTI International is an independent non-profit research institute in the US. She holds a PhD in energy systems at Duke University, North Carolina. And her paper is Economic Supply Chain Impacts of Expanding Electricity Access in Kenya. So please, Candise, you can share your screen.
Great, thank you. Please. Can you see this?
Yes.
Great, thank you. Hi, everyone. My name is Candise Henry, and today I will be talking about a project that we've been working on at RTI, led by my colleague Jared Woolacott, on the economic supply chain impacts of expanding on-grid electricity access in Kenya. The framework that we present here was created by RTI, but leverages data from a Power Africa program funded under USAID, the US Agency for International Development. So I think everyone here knows that electrification has been a major focal point for bilateral and multilateral development efforts in recent years. International donors like USAID have contributed billions of dollars in aid for electrification efforts around the world. And this is because there are important economic development and environmental benefits from electrification. Much of existing literature is focused on end user benefits of electrification, and discussions of investment priorities are often around whether there are causal effects of electrification on end user benefits. However, there are also supply side benefits from building and operating more electricity generating units that could be useful to consider in discussions of investment priorities. So some background, a quick literature review for these benefits. I'm sure many of you are aware of these, but we kind of bucketed the broad existing literature on end user benefits into four main buckets that are health outcomes, educational outcomes, women's empowerment, and income generation and economic growth. For health outcomes, there are benefits of electrification in terms of decreases in indoor air pollutants, improved nutrition due to refrigeration, and improved access to life-saving medicines. In terms of educational outcomes, studies have looked at how increased access to light can increase study time for students. In terms of women's empowerment, outdoor lighting can increase public safety. And then there's studies looking at how gendered social norms can change due to increased access to information. And then in terms of income generation and economic growth at the household level, increased access to electricity and light can allow for more time for income generating activities. And in the long run, households can reach higher paying jobs due to increased educational outcomes. And then for the broader economy, there are increases in productivity due to increased use of machinery, and also households that become richer will spend more on the economy. Then in terms of the supply side benefits, investment in electric sector capacity supports a variety of economic activity, from equipment purchases to labor that manages construction, to the materials, energy, and services to support this construction. And there are three, main groups of benefits that we consider. There's direct wage benefits, indirect wage benefits, and induced benefits. So in terms of direct wage benefits, these are investment dollars spent on wages for those that are constructing the actual facilities. And so this direct wage benefits are to the local and regional residents participating in the construction of a project. For indirect wage benefits, these are expenditures on procuring goods and services to support construction throughout the supply chain. And then finally, when wage benefits are local, the wages are spent for consumption that induces another round of spending in the economy. And so these are the three types of supply side benefits that we investigate. And the estimation of induced benefits is trickier because of potential double counting of benefits. So for this talk, I'm just going to focus on the direct and indirect benefits here. So the research questions that we're interested in trying to understand are, what are the supply chain benefits of electricity expansion in Kenya, focusing particularly on renewables? And then what amount of skilled and unskilled labor will be required to meet Kenya's capacity expansion plan into the future? So Kenya's least cost development plan for electricity expansion. And in order to answer the first question, we will be examining the direct and indirect wage and job impacts of on-grid electricity expansion. And then to answer the second question, we will be assessing the implied occupation level indirect job impacts by combining the GTAP and data from the International Labor Organization, ILO. GTAP provides occupation level wage payments, but no corresponding jobs information, while ILO provides detailed occupation level data, but coarser sectoral resolution. And so by integrating these data sources, we can get more information on jobs impacts. So our approach leverages a range of data, as you can see in this figure here. Starting all the way from the left, we use Power Africa. So USAID has a program called Power Africa, and there's a database called the Power Africa Transaction Tracker, PAT. And this is basically information on USAID-funded projects historically until now, and what the technology type and size is, as well as the financial and commercial operation dates. So that's what we use for our historical information. Kenya's least cost development plan, the LCDP, provides us with information on what the projected capacity expansion will be. So we'll use PAT for our historical projects and LCDP for our future projections of what investment projects will look like. And with all of this, this generation capacity information, we will combine it with the National Renewable Energy Laboratory's annual technology baseline data set, ATB. And ATB provides us with estimated CapEx and fixed and variable O&M costs for different technologies. And with these three data combined, we can estimate, how much projects have cost in the past in terms of construction and O&M, and how much future projects will cost. And then taking this project level data, we will divide it out into where in the economy, which sectors this spend actually goes to, using NREL's IJETA dataset. And IJETA stands for International Jobs and Economic Development Impacts. So IJETA provides data for different technologies on basically what types of, for a construction project, how much of it is spent on different materials and different parts of construction. And we're able to map those breakouts into GTAP's 65 economic sectors, so we can know for a given project which sectors that spend actually goes to. So then with GTAP and the ILO data, we combine these to estimate multipliers for understanding what the jobs quantity and wage impacts are in terms of direct and indirect impacts for each of the projects that we have. So our ultimate final outcome that we want from this is information on what all of the investment in Kenya's power sector, renewable energy, will be in terms of direct and indirect jobs and wages. And just to show a quick figure, this is what USAID's historical and planned capacity investments look like that end in 2025. And so USAID investments between 2015 and 2022 make up roughly 30% of total new capacity in Kenya. And much of USAID's past investments are in wind and geothermal, but there's also solar, hydro, and biopower. And then this is Kenya's LCDP projected investments going out to 2040. And so you can see there's a lot of projected investment in geothermal, as well as hydropower and solar and wind. So basically with all of this quantity data, we will again map it to ATB to get estimates of future capital and O&M expenditures, which then we can again attribute to different economic sectors in terms of direct and indirect benefits. So in order to estimate the direct and indirect benefits, we need to obtain input-output multipliers. And we do this using GTAP's Power version 10 database via Tom Rutherford's GTAP and GAMS code. And labor multipliers come from integrating ILO data with ILO employment by industry and occupation data with GTAP. And what you can see in the tables here on the left, these are the multipliers that we obtain for direct and indirect wage impacts. And then on the right, it's job impacts. So on the right, it's jobs per $1 million. And I will note that the multipliers here include the impact of local purchase coefficients from GTAP's trade data, but also project-specific inputs from NREL's IJETA database. And we apply, of course, local purchase coefficients here because we are focused on domestic impacts and we are not looking at expenditures and money that is flowing out of Kenya into other countries. Okay, so some results that we get from this. Here on the right, it shows capital expenditures by sector. This is from 2015 out to 2040. And in the top figure is the national capital expenditure. And then on the bottom, this is Power Africa specifically. And because Power Africa projects for now only go out to 2025, that's why it stops there. And what we see from this is that capital expenditures are dominated by extraction due to a high level of geothermal. So in this figure on both of these, the top and the bottom, the brown gray color is expenditures for other extraction. And again, because geothermal is such a big component of past and projected future generation capacity, a large part of expenditures will be on the other extractions sector. Construction services, which are highly local, are the second highest. So this is what you can see in the green across both of these figures. And again, because we don't look at international, we only look at local purchase coefficients. Other expenditures going out of Kenya would not show up on here. And I'll also just note that there is a expected uptick in capacity additions between 2022 and 2025 because there's really lofty capacity expansion goals from the Kenyan government. And then in terms of operations expenditures, so these are expenditures that will incur after a power plant opens for the operation of the plant, of course. What we can see is that O&M expenditures are rising steadily, given demand projections from LCDP. And other extraction is still a really large component of this because operations of geothermal is predominantly local and it requires local expenditure. And what you can't actually see here is that machinery and equipment are the second largest expenditure. So that would be in light blue, just above the pink in some of these. And machinery and equipment, even though it has the second largest expenditure, it has relatively low local purchasing coefficients. So for a lot of technologies, the expenditures are exported out of Kenya, and so it doesn't show up as necessarily as the second largest. Okay, what does this mean in terms of direct and indirect income? So here we see what the projected direct income will be across out to 2040. And the blue is direct and orange is indirect. And we see for most years, direct is greater than indirect because direct income for construction in our analysis includes only construction, extraction, and electricity expenditures. And since, again, there's a lot of geothermal extraction, there's a significant local direct income impact. And I would be remiss not to mention this giant peak in 2026. And this is because of the way that because of some of our assumptions, but there is an expected large hydropower retirement from KenGen between 2027 and 2028. And so in our analysis, we assume that to make up for this retirement and to keep up with LCDP's capacity projections, there will need to be new construction that ends by 2026, 2027 in order to offset this large retirement, which is why there's such a peak in completed construction in 2026. In reality, this is probably going to be spread out across more years, but we didn't want to make the assumption of how that would be spread out. It's really interesting to note, though, that this is going to be a very large project. And so this $2 billion is actually roughly 2% of Kenya's 2020 GDP. So it's not an insignificant amount. And then in terms of the construction impacts on actual job numbers, so here in the y-axis, we have the number of jobs rather than total income. And what we see is that there's a potential for roughly quadrupling of jobs impacts to support projected capacity expansion over the next 20 years. And in addition to that, there's a potential for significant labor shortages if we have to offset this large scale retirement of hydro before 2028. In terms of the operating impacts on direct jobs, so here we see that jobs supporting operations will expand by an order of magnitude from roughly 10,000 to roughly 100,000 by 2040. Again, primarily due to the extractions, primarily in the extraction sector due to geothermal. And so because it's geothermal, you see a lot of the direct impacts in blue as opposed to the indirect impacts or indirect jobs, sorry. Okay, what does this mean in terms of where the jobs actually occur? So, or what types of labor is actually occurring? So here we show the results of construction and O&M combined. And again, this is still number of jobs. And what you see here is across both construction and O&M, we will get predominantly laborers, which is in orange, due to geothermal extraction. But there is an expected at least increase in more skilled labor. So some of the other colors like the gray one, which is managers. So there is some expected increase in more skilled labor, but predominantly it will be in the unskilled labor category.
2 minutes, Candise.
Great, thank you. So the main takeaways here from this analysis is that there's potential for roughly quadrupling of job impacts to support projected capacity expansion over the next 20 years. Jobs supporting operations will expand by an order of magnitude, again, primarily in the extraction sector due to geothermal. Job expansion is predominantly for unskilled labor, but the scale of expansion will require jobs training for other skill types as well. And there's potential for substantial labor shortages leading up to 2028 due to these large-scale hydropower retirements that are expected. So some future work that would be useful here would be to refine the quantification of labor impacts. So I didn't go into this during the talk, but using our multipliers from the GTAP and ILO data sets, our implied average wage is around $1,160 per laborer per year, which is lower than the 2020 GDP per capita, which is at 1,838. So roughly 1,100 versus 1,800. Which suggests that our mapping of labor categories into expenditure categories could be further refined. So, that is an area for future research. Skills assessment of the labor pipeline to support capacity expansion could be interesting. And finally, exploring the job impacts of alternative expansion scenarios. So, in the LCDP, they project predominantly geothermal, but what if that's not what actually ends up happening? So there might be other scenarios that we want to explore and understand how that impacts direct and indirect jobs and wages. And with that, I will conclude and take questions, I guess.
Thank you, Candise. Very interesting, excellent presentation. Impressive work to combine 6 databases to answer this question and do the modeling. So I'd like to ask if anyone would like to raise a hand and ask a question or write in the chat.
It looks like Erwin has his hand raised. Is that?
Yeah. Okay, so yeah, thank you for this excellent presentation. I have one comment and one question. So for the comment, yeah, you were right about GTAP not providing the labor volume. I'm not sure how it will be how you will benefit from this, but for version 11. We will be having an update of the wage and employment data in the GTAP database. And then on top of that, once the standard database is out, we are creating a new satellite data called GTAP Labor, which will provide the wage and employment split for each occupation type by industry that will add up. So basically, it's just giving you how the value flows are constructed given a particular wage and employment split. And then on top of that, we are planning to combine it with the World Bank's gendered data, WGLD, I think, if I'm not mistaken, for the acronym. So that we will have a 5-dimensional wage matrix, wage and employment matrix that tracks employment by occupation type based on ILO, by gender, by education, by industry. And then there's another one that I'm missing, but so basically, it's a 5-dimensional matrix that will allow you to look at or aggregate labor however you wish. So, for example, if you want to aggregate it by occupation, you can do it. If you want to aggregate it by education type, you can also do it. So that's in the pipeline and should be coming up around next year for the satellite labor database.
Oh, thank you.
Sorry for the long
Yeah, that was
comment.
really helpful.
And then my question is, let me put on my previous private consulting hat about multipliers. So the normal question we get whenever we use multiplier is that they tend to be overestimated, right? The question, well, I missed something, but probably you alluded to it during the presentation. What's your cost benefit ratio for this one? And if you have that, how big is the cost benefit ratio? And probably you can give us some indication so that whenever people complain about multipliers, at least we have something to give them some guidance about these things. Thank you.
Yeah, thank you. That's a great question. And actually, my colleague Jared was the one who did the modeling analysis. So he is on the line. Jared, could you take that question?
Happy to. Thanks, Candice. Yeah, it's a short answer. Unfortunately, we didn't do about cost benefit calculation yet. We've just been focusing on the multipliers and in tallying up the labor impacts. But this is a work in progress. So we'll certainly incorporate that in our final report. And any additional thoughts you have there, Erwin, as to what we might be looking for and some reference points would be welcome.
Okay, yeah, thank you. Just maybe combine the national direct and indirect impacts and then look at the cost that you're imposing and then just give an indication. At least that will give those who are against multiplier analysis something to look into. Thank you.
Yeah, thank you. And we'd be happy to share when the paper is complete, the results that we have there.
Okay, next question. So may I ask a question from me? So I had a question regarding labor impact. Did you take into account potential long-term benefits of electrification in the sense of the change of the production structure of Kenya? For example, if they manage to pivot from some raw industries into more advanced industries that require like accessible electricity. For example, instead of shipping raw coffee, they could start shipping roasted coffee or same as chocolate for coffee for cocoa beans. If this kind of more long-term industrial thinking was also part of the model.
Yeah, that's a great question. We did not consider the full long-term impacts on the entire economy, the full economy on the really long scale. But that is something that obviously is very important and is something that we would want to consider, but I imagine much more difficult to quantify and incorporate into an analysis of this sort. There would be a lot more assumptions to be made on some of these impacts and components, but definitely worth considering. I think that's a great point. Thank you.
Thank you. Do we have more questions? Okay, if there are no more questions, I think we can proceed to our next speaker. So we are well on time. So our third speaker is Thierry Kinkpe. who is a PhD candidate in agricultural economics at Humboldt University in Berlin, Germany. He has several years of experience in agricultural economic research at research institutions in Africa. And today his paper is on CGE modeling of agricultural growth through food processing supply chain development. So please, Thierry, yes, you can, the floor is yours.
Thank you, and thanks all of you to be attending my presentation, which is on sustaining agricultural growth through food processing development. And for this, we did a CGE analysis for Benin. This is a part of my PhD research, which is supervised by Dr. Jonas Lukman and Professor Harald Grete. I think Dr. Jonas Lukman is also online now. And my name is Thierry Kinkpe. I will be presenting this. As background, in the last decades, most of the African countries, following the recommendation from African Union and regional policy orientations, are setting up agricultural development plans that they are implementing. In the case of Benin, they have an agricultural development plan that they call Kniahin, which is National Plan of Investment in Agriculture for Food Security, for food and nutritional security. And this is targeting to enhance productivity in agriculture and improve value chain for agricultural products. But how does it happen in reality? The policy document is not that clear on it. From the literature, we learned that agricultural development without suitable value chain developments may end up by negative effects on farmers. And especially in Benin case, a study showed that increasing productivity in agriculture leads to lower agricultural prices and income loss for poor rural households in Benin. So that was the background guiding my PhD, and based on that, I did the first paper to show how it can be if the agricultural development was driven by food processing development instead of developing the agriculture directly. So this figure here is showing the welfare effects of food processing development to process at least 50% of agricultural production for some commodities in Benin. And we saw that this produced a positive welfare effect for rural and urban households, while rural households is profiting more than urban households, and the path of the growth is pro-poor. So this shows that food processing development improves livelihood of the population, but how exactly can food processing develop? That is what we are going to talk about in this research, in this paper. As part of the project, we did an empirical study in Benin. And one of the steps was to do a strength, weakness, opportunity, and threat analysis of the food processing sector. And this analysis shows that lack of electricity supply is one of the most important bottlenecks of the food processing development in Benin. As most of the African countries, Benin is not yet fully covered by electricity network, especially in rural area where we have most of the raw material for the processing. So based on this, we studied how it works with the food processing sector in Benin right now. So as energy used in the food processing sector, what is happening is that the factories are using conventional electricity, which unfortunately is insufficient and is not stable. Most of the time, we have shutdown for electricity supply and so on. So to supplement this, the factories are obliged to use generators. And the electricity produced from generators, as you know, is quite expensive. So that the use of the conventional electricity and the generators produce what I can call mixed electricity. And this mixed electricity, together with non-electric energy, is the total energy that is used in factories to process food in Benin. But how generators work? What is the source of the non-electric energy? To make these generators work, they need fuel. The factories need fuel, and about 50% of the consumption in fuel is used for electricity production from generators, and the remaining is used as non-electric energy in the factory. So this is the background about energy use in the food processing sector in Benin. So, but since some years, the government is making efforts to improve the electricity availability and the stability in Benin. They are working hard for self-sufficiency. For example, in 2016, maybe around 10% or maybe a little more than 10% of the electricity is actually produced in Benin. But already in 2019, Benin was 50% self-sufficient in electricity, and they are still continuing with the production of to improve the electricity production. And most importantly, they are creating industrial zones for food processing with stable electricity supply. So this brings us to the research question: if the stable electricity and sufficient electricity supply can induce development of the food processing sector and thereby enhance agricultural development and overall economic development in Benin. To address this question, we used a social accounting matrix, a 2019 social accounting matrix built for Benin by me in the frame of this PhD. And in this social accounting matrix, we have agriculture providing 29% of the GDP, food industry 3%, non-food industry 3% also, and construction 5%, while services are providing 60% of the GDP. This social accounting matrix has really important details on agriculture sector and food processing sector. But for the purpose of the current paper, we did some modification on this side. One of the modifications is about the sectors. We first create the stable electricity sector, activity and commodity, from the electricity sector existing in the SAM. And also, we create another activity which is called broiler poultry meat trade, because in the original SAM, the broiler poultry meat is also smuggled to Nigeria. And this smuggling is making the domestic production doesn't cover the exports. The share of the export is covered by the imports. We also worked on the production factors in the social accounting matrix. So in the original SAM, we have labor into two, unskilled and skilled labor. We hear from unskilled labor, the labor that doesn't have any formal education or at most only primary education, but the skilled labor is well educated. We have also capital in this SAM, and we split it so that the effect of our policy simulation can be captured well. We split it capital into four: agriculture capital, food processing capital, new electricity plant and network for food processing. This is another capital in, which is used only by stable electricity sector. And we have other industry and service capital. We also split it land, sorry, into three: permanent cropland, annual cropland, and husbandry land, so that the effect of the policy simulation can be well controlled. We use this SAM to simulate to do our simulation using a stage model, the second version of the stage model, and the closure we applied was fixed exchange rate regime, because Benin, as most of the West African and Central African countries, has fixed exchange rate regime. And we had fixed CPI, which was the numerator in the model. And the model is saving-driven investments. The government saving was flexible, while the household income tax rate was fixed. And the small country assumption was used so that the world market price is fixed for the country. About the scenario we implemented, I was explaining, we tried to develop food processing by developing stable electricity sector. And that was the basic idea behind the scenario we implemented. And as I was explaining before, this system, which was existing, now will be shocked by more production of food, of stable electricity. And this stable electricity coming in the system will decrease the demand for electricity from generators first. And then, because this one is the most expensive, and then also the normal electricity that we were using, because this with the stable electricity produced more is cheaper than the other one. And with this system, the energy used for the food processing become larger, and this make the capital used for food processing more efficient. So, as scenario, we implemented a double stable electricity production. So when the stable electricity, as it is now in the social accounting matrix, is doubled, what happened? What happened is the food processing sector individually grow, but differently, because they don't have the same energy used share in the beginning. So this brings to a shock of 26% on bicycle poultry meat and broiler poultry meat, because they are a kind of this mostly the same kind of activity, and other slaughtering also 26%, but pineapple juice 14% when it is industrial pineapple juice. For the artisanal one, it is 16%, and so on. So the shock is made specific to the capital for food processing, but also specific to the sector because of the differentiation in capital, in energy consumption of each sector. As a result of this shock, we obtain almost 9% increase in food industry. So this means that when stable electricity became more available, the food industry grows. This induces growth of agriculture food production. And one of the consequences of this growth also is the decrease in non-food industry. And this is driven mostly by cotton sector, because cotton is one of the most important export products in Benin, while some other food industries are also exported. So when these food processing industries grow, something else, the export increases, and the non-food processing sector need to export less. So this brings to less food industry, non-food industry development. But something else which explains the decrease in the non-food industry also is that pineapple, for example, which is one of the which grow the most because of the food industry development, is competing with cotton in terms of land. So This increase in production brought also to decrease in producer price for food industry. Producer price for food industry is decreasing slightly really less than the food processing development itself. While agriculture price is increasing and the other industry and services prices are also increasing. Now, looking into details in the food processing sector, we notice that, as I was saying, pineapple juice industry sector is the one growing the most because of its share in energy use, but also its share in exports, because the export price is not changing, small country assumption, so the production can go direct mostly into export, and this makes the sector grow the most. We have the next growth from the cashew kernel industry, also because cashew kernel is mostly exported in the country, and this is not disturbing the local economy that much. Looking at the consumer price of this food industry product, we notice that 17%, the pineapple juice price of domestic consumption decreases by 17%. And this also allows consumer to consume more of this product and bring some welfare effects to them. The other sectors like bicycle and broiler poultry, the prices are increasing a little bit, but in most of the food processing sectors, the prices are decreasing. As conclusion, we notice that more stable electricity makes the food industry grow. And this growth is higher for industries with high export share and energy intensity. That was one of the most important lessons we learned from this. And the food industry development sustains agricultural growth. Higher the industry growth is, higher the growth of the agriculture sector, providing the respective input is. As implication, we can say that investing to make electricity stable and available allow developing food industry for better sustaining agricultural development. And here we have further research which consists on extending the production nest in our model, and this is ongoing. So, of course, what is in the model right now is that we have capital combined with labor for the food industry, and labor, we have two categories, skilled and unskilled. When capital and labor are combined in value added, they use intermediate inputs to produce the output. But as I was explaining in the beginning, what is happening really in the field is that we have unstable electricity, which is mixed with fuel use to produce mixed electricity. And when stable national electricity comes in, it can substitute this mixed electricity, which is expensive for the farms. And this will lead to the electricity used in the factories. When this electricity is combined with non-electric energy, it will be the total energy used in the factories. Now, as the energy growth, as one of the information from our empirical study is, people are willing to invest more in food processing sector when the energy is more available to them. So we will combine this energy with capital together, and this will become capital energy complex and the value added energy here, and the intermediate input will not include electricity anymore, it will not include energy anymore, but it will be other intermediate inputs. So this is what we are implementing right now in the model. This is still ongoing. On this, I can say thank you for your attention, and I will really appreciate your comments and questions so that we can continue better this work. Thank you.
Thank you, Thierry, very much for the excellent presentation. It's excellent that you brought this detailed data with different types of electricity and stable electricity as an input, and your sum data set for Benin. So I hope this will be important results that will inform policymakers in Benin with food development, food security. Do we have questions from the audience on Thierry's presentation? You can write them in the chat, or you can raise your hand.
Oh, can I ask a question? So I couldn't find where to raise the hand, by the way.
Yeah,
So
please go ahead, Onur.
Yeah, thank you for the presentation. I think it's really interesting. I just have a maybe silly question. So as we know that global value chain, in terms of global value chain, it's really African country couldn't improve the participation in general, right? So what is the takeaway from this study? You think if investment increase in energy intensive part, then food sector increase, and then do you think that helps the African country, especially Benin, then participate the CVG more? Is one of the question. And second one is what about logic? So we believe that the basic investment is that the more you invest in let us assume food-based sector, the more you expect that there is a sectoral outcome from the manufacturing sector. So you think this is the different causality between this logic? Maybe this is the question. If it is, just ignore. Thank you in advance.
Okay, thank you. Yes, as you said, the most important message from here is that developing the electricity or the energy sector in countries which are agriculture-based help developing the processing sector, the industrial sector, which use agriculture product as inputs. And this contributes to develop agriculture without harming farmers. Because as background, when agriculture is developed based on productivity increase, and there is no thing done on the demand side, this leads to decrease in price. And this decrease in prices can harm farmers. So if agriculture development is induced by the food processing development, which can be induced by the energy development, this will lead to what I can call sustained agricultural development, because the whole system will be working together. So that is the message. And I fear that I did not get well the second question. Would you please?
So if you check the Untitled report recently, or 2001, they're focusing some African countries. They're saying that they are not diversified the product. So they're mainly import or export, primary or agriculture product. That is actually the problem. They couldn't improve the participation. But in your analysis, you're saying the more you invest in a energy intensive product, maybe food product related, that is also improve the outcome. So, but your analysis also show maybe just putting some strong assumption in food sector that also consequence of the reduction in manufacturing sector maybe. So my question is like, how this causality, like what is it work, this causality? You think is it make sense?
Yes, okay, thank you. Now I get it. In the case here, as I was saying, the food industry is linked also to exports, imports. But the non-food industry also is linked to exports and imports. For example, the most important product that we export from Benin is cotton. And this cotton is competing for lands, for example, for something like pineapple. So if pineapple production is going really much, it takes land from cotton. And this brings to decrease in cotton production. And then the cotton industry also production need to decrease because the industry just process what we produce in the country and export it later. Okay, but secondly, the cotton as it is an exported product compete also on the world market price, you know, the trade balance problem. Since pineapple and cashew are, as raw material are exported, but as also processed products are exported. So when the export of these two products are increasing that much, something else, export of something else need to decrease. That was the problem with cotton, which is driving this decrease in the non-food industry. Because we make the capital sector specific. The non-food industry is not competing with the food industry in capital, for example. So the mechanism behind this decreasing in non-food industry is driven by the what is happening in agriculture based on cotton. Thank you.
Yeah, can I ask a small follow-up question? So continuing with your cotton example, so why does electricity not benefit cotton processing industry in Benin? Because as we know, Benin is shipping cotton to China, to Bangladesh, everywhere, but it's not exporting t-shirts and shorts and other clothing as much. So maybe electricity could also have this impact.
Yes, of course. Electricity development can also impact positively cotton industry. But here we only targeted the food industry. As cotton is non-food industry, our shock did not go to the cotton. The stable electricity which is produced now is used by the food industry. And this is based on the fact that the government is setting up industrial zones for food industry. So the cotton industry exists already, is quite developed, but what is going on right now is to develop more the food industry so that we export less as raw material, but more as final product. That is why we did not implement the shock on the food industrial sector, but only on food industry. But yes, the development of electricity.
I think you might also do different assumptions comparing each other. Maybe this is another insightful, you can present using the different assumption like food sector, like manufacturing sector, or all the sector, so then you can compare. That will be the different outcome.
Okay. Thank you.
Thierry,
Yeah.
I may have missed it, but could you clarify again how you implemented the shock to make the electricity more resilient, for example?
Okay. Thank you so much. As I'm sharing again my screen. Okay, as I was saying, what is going on in reality is the energy growth will induce something on capital. And these two guys will come together as capital, energy, and value added. Since the model development is not fully done, we implemented the shock finally directly on the capital used by food processing. How? When the stable electricity supply doubled in the economy, what will happen is its price decreases, then the industries consume more stable electricity and decrease their consumption for diesel using generators. So this brings the whole energy use quantity up by 25% when we calculate it. But this 25% is not equally distributed according to the sectors, because each sector has its own energy used at the beginning. So this energy used at the beginning of each sector is behind this difference between the percentage of the shock here. So when the stable electricity supply double in the economy, the bicycle poultry meat energy use will increase by 26%.
Okay.
And so on.
Yeah. So you're imposing a productivity shock. Is that right?
Yes, the efficiency on the capital used by these sectors by this percentage.
Okay.
That is what we did.
All right. So in that case, capital will become more productive, and then the use of capital will fall. Well, maybe we can just do it offline, but what I'm saying is you increase productivity, the marginal product of capital would increase, right? Anyways, yeah, we can do that offline. Yeah.
Thank you.
Okay, thank you very much, Thierry, again. So we would like then to move to the final presentation of today. So it will be Onur Biyik, PhD candidate in international economics at Waseda University in Tokyo, Japan. And his paper will be on measuring double counting in multi-country global value chains, and also knowledge spillover effects on global value chains. So please, you can share your screen.
Yes, I think, can you see?
Yes, we can see.
All right, let me try. Yeah, okay. Yeah, I can imagine everyone pretty much tired here. So I will try, I can't promise, but I will try to make it short. So most of the theory perspective, I will skip, and much more detail, I think you can go to original paper, you can see. So this is the global value chain perspective, trying to show double counting in mystery, as well as introducing the knowledge flower in CVG participation. So the content is after introduction motivation. So I will summarize the basic matrix model and then introduce the two different contribution evaluated in export. So we try to explain the domestic variable foreign value in the end country model, and then second part I will introduce the knowledge flow in CVG participation. So main logic here is that I try to show that there is a complexity of double counting. Sorry. As multinational company expand around the world due to the cost efficiency location. And then after that, the production process of global firm have become increasingly complex. So on the right side of the picture, you can see that this is the EU raw database. It's quite complex among the country within sector as well. And this is the one of the idea it's coming from that when goods leave the country, and it is really impossible to with available data source, of course, to track where the goods are combined and with the part-time component and services. So this is the main idea. And then the second picture, I just want some like portray this perspective. This is the Volvo S40. It's quite common recently, I've been seeing lately. And Volvo company actually assemble most of the product from the world, Japan, EU country, US, etc. So one of the example is that air condition, for example, the process maybe start from Germany, it's sent to Italy, France, and then it's assembled in France and then send it to the car company to merge in a car. And then this car may be sold in France. Then we are questioning like how to measure the double counting. So in literature, scholar investigate where the value added was created or upstream downstream effect of the value added, as well as measuring the value added exchange rate, factor content, and international inflation spillover. So this kind of assumption is rely on strong assumption and try to address the where this kind of product observed. So in same line with, I question what is the challenge of measuring double counting in relation to in-country model? What role does the spillover or knowledge spillover play in the increasing the value added perspective? So this paper contribution, previously, I would like to say that this paper is similar with the Koopman et al. 2010-14 Johnson Laws Wang paper concerning double counting. As I mentioned before, this paper show where the products end or which country or sector receive this product. So this is actually pretty consistent with the theory basis that last stage production from, especially if you estimate from the input-output databases, this is consistent, but their assumption in terms of the theory, they portray the two-way of trade export or three-way of export. So in practice, when I checked this literature, I saw that they trade the third partner as a unified country and then segment the product and in terms of the foreign value added or domestic value added. So in my conclusion, the literature lacks an N way of intermediate import-export in multi-country integration. So then relatedly, this research contribute international trade flow in terms of continuous integration of the CVG participation. So this is the production stages. And so third country in a more than, end trade way leads to complete integration, I call intervening trade or continuous integration. So then second perspective of this paper, because of the vertical integration upstream and downstream stage, this provide more integration or more positive effect. So this give idea us to merge, there is some knowledge spillover within CVG participation. So let me start with the basic matrix. This is the quite common matrix. I don't want to repeat that much things, but A is the input-output matrix. So if you do basic matrix, you can get relative inverse matrix. So this is the matrix that we can show that this matrix show that the input from each sector met the needed to produce a unit of the output in each sector. And to show vertical integration, we, in line with literature, of course, they compose the Leontief matrix in terms of the local equilibrium and feedback effect and bilateral spillover effect and feedback spillover effect from the multi-country perspective. And then next stage, we focus on the value added in terms of we decompose the final demand as a domestic final demand and gross export. So we just use this decomposition input into the equation to create the 5.1. So this is actually the matrix where we use we employ the Koopman to create value added in final demand. And next stage is we focus the value added in export. In terms of this person, that we use the location perspective. So this is the N by N diagonal so we can find we can track the location where the value added was created or is pursued. So in terms of the equation 5.1, we modify equation 5.1 to create 1.1 star that we can estimate domestic value added as a diagonal part and foreign value added as the sum of the column. The next stage is we start from the domestic value and export from the two-country model. If we extend the intermediate product function of future consumption or production stage, then we under the proposition 1, proposition 2, we supposed to get 6.2 equation 6.2. We just multiply here, so that's the basic mathematics. It's quite easy mathematics. So we can get the bilateral integration and upstream and downstream integration here. We just transfer this one as an observing in a foreign and domestic perspective in line with the Koopman paper. So just here intermediate observing as this is proceed and export back R. So this is the double counting actually that how they estimate. So when you try to estimate in country model, so first of all, we already defined here, we just adding multi-country, that is the straightforward one country with multi-country is the straightforward. But as I say in the literature, we don't know how the third country distribute their export within partner. So then we need to define third partner. So here we created the third partner relation. Let us assume n country, n minus 2 country has a n minus 3 integration. If you extend this version in terms of the trade value between countries, so you can get the K. So this is the T. I mean, I just want to skip this since I have a limited time. Let us assume here we assume that country, we define R is a country, I is a sector, K is a country sector pair. So intermediate flow between country is the P, and then it starts from the product produced in Kn minus 1 are sold to the Kn minus 2, so on and so forth until the product arrive K, that the input, so intermediate input put into the final product that are shipped and sold to the consumer R. So this is the final reach, but this is the straightforward is the bilateral. So we don't know the multilateral integration. Most of the literature characters couldn't characterize the asymmetric of the cross-country production. So then if you do basic mathematics, so we get this extra version, we call this is the intervene product or intervene trade that we just merge it here. And we combine the domestic value under the limitation. We estimate domestic value combination equation 8 and 8.3. Then we create it. So the limitation again here, this is the number of T countries have a trade integration with RRS and T minus N countries. So that also has an integration T minus 2 countries. So this is the going process until, as I say, the product consuming X. So under this limitation, so we just also estimate, we also show the equation valid for valid in 2 country and 3 N country is basically in equation 10 and 11 more detail. We can just, so we question, is it clear to eliminate return home part? So the equation 8.2 and 8.4, this isn't possible to track because there is a continuous stages. And the return home part become impossible to track and then eliminate. So then we propose estimate. So we propose the optimal estimation based on equation 5.1 star. Then basically how we estimate domestic value and foreign value that we use the input output databases, the most common use, the examine CVG, and we construct or develop the GTAP Mario databases based on this and here, and then we focus 3 region and 4 country. This is the so this is the I result. So we focus to different portion here. So this is bilateral integration. This is multilateral integration. This is not a matrix. This is the contribution of sectoral linkages to sectoral outcomes. So when you increase the export or import, how this matrix, each matrix increase the export and so increase the output of the sectoral output, so based on the sectoral linkages. So then we found that this is the contribution that once the product cross the border 2 times, let us assume return to home, that's the causing home bias. This is the one of the contribution here. This study is the consistent with the WTO. They also estimated like Germany 1.7 something. It's lower than 2%. So there's a many feature here. We can also focus on sectoral basis and bilateral and multilateral perspective. So second stage is that we also found that there is some upstream and downstream positive effect that is actually showing that there is some extra integration. We know that CVG is one of the important channel of knowledge flow drive the innovation. And this innovation actually coming from international trade, FTA migration, but my study rely on the international trade that it's import product perspective. So this channel is important because there is a high intensity between foreign and domestic supplier, and also because of the production process, efficiency of the production of the outsourcing firm, that is actually the foreign firm need to exchange the knowledge, etc. And under this assumption, we create the proposition for so knowledge flow is relying the production process among certain country is integration marginally distributed. So we follow the Bonzi and Perry paper. We created the knowledge flow assumption, knowledge flow equation. This equation 12 actually, NRS is the knowledge flow in relation to distribution probability in export. And this is the import. So international knowledge flow embedded in tradable goods. And if we continue regarding the Bedouin and Yan, if we assume that there is some end stages, production stages, this is actually performed accumulating over time. So this is the production stage of continuum input. So this is when the input cross the border 2 times. First time, the product consuming domestically, and second time when they start exporting the other country, they accumulate or they separate or transfer the knowledge among all the country based on the accumulation effect. So then this is the line in line with the Antras and Danzi model. And in terms of the knowledge flow and sectoral integration, we believe that if there's some knowledge, this knowledge going through the sectoral integration. So then in this logic, we employ the Tefler and the Zoo to merge knowledge flow with CVG participation. Again, 5.1 to start just merging diagonal the technology. This is the consistent of the how this knowledge flow effect on export as well. The empirical consistent, the estimation technique with the theory consistent empiric work, we use the patent panel databases. So then first the patent citation between 2001 to 2010 from the patents data, and the trade data is coming from the Ontario Comtrade, and the other gravity equation coming from the geodistance variables, geodistance databases. So then we use the linear log linear version and PPML, so PPML estimation method, so that knowledge actually patent citation actually present the log of the number of patent citation, which account all the application in country R to country S, and in industry R, industry GA in year T. So this is a log version. This is the percentage knowledge flow. IMP is the represent the bilateral trade flow import. So control variable, we have distance, we have language and border. So we also control the sector fixed effect and then year fixed effect. So it's known that patent citation is a non-negative. Also, a lot of zero variable. We can employ many different equation, corner solution, etc. But mostly common estimation method is a negative binomial regression or PPML regression. So this is the result. Again, just want to skip this focus domain idea. So I just please follow this stages that so we use the region, all region. We have, sorry, I skipped the part, sorry. Yeah, we have the data cover the 14 region. So knowledge flow and the patent, sorry, patent data and the trade goods were merged based on the SMASH. So they have the data, documented data, and so table that we merged based on this one. So estimation, we rely on the single country perspective. We focus Japan here. This the variable that one import increase, then there is some knowledge flow increase based percentage of the 0.06 or 0.06 percentage. So then we can estimate optimal spillover effect that traveling goods regarding production stages contribute more by 1.6 to 154 percentage, and as infinite and twice and infinite. If we focus on value-added in terms of the, if I go back here, this is the value-added perspective. This is the average of the sectoral average actually. If we want to estimate average, then we get the 0.8 to 72 percentage. So let me summarize here this. So what we did study, we focus on the challenge of double counting and knowledge flow with the CBG participation. So what is the challenge of measuring double counting? We experienced that there is an intervene on continuous trading integration that we couldn't estimate the origin of the product, or we couldn't track the origin of the product. Then we propose optimal double counting is the 1.5 from the input output database. If you actually imply the sector linkages each like final or sector, then this one is become really small, unless if there is some unbounding. Let us assume Japan, China has a quite integration flow that actually this is the concern we have to take into account this double counting, be carefully. And what role sorry?
2 minutes, Onur.
Okay, so so we experienced that the more the product travel, the more they contribute to the value added. This is you focus on single country, but this is not a Japanese GDP. This is the production stage that the more they travel, the more they contribute. So the comparing this result is consistent with the theory and empirical basis that Calindo and Perro, they estimate if there is no any intermediate trade, the result is like decreasing GDP lower by 3 to 7%. If we assume there is some shock in related to the value, the sectoral contribution coming from production stage are more likely to diminishing by 0.8 to 70%. This is really important to take into account the knowledge flow because it is essential to estimate or calculate the impact on economic growth. So if we suggest something that the more you diversify product, the more you learn from the knowledge from the distance partner, and also this is also helped to increase the welfare GDP, also improve the recovery, recovery dynamism. So what we should take away, this is the maybe helpful in terms of the diversifying and contribution. The word is one of the things that maybe tariff facilitation agreement or tariff maybe under the WTO to eliminate the distortion. Of course, we can imply not only single country, two country model, but if there's a problem that this actually import is really important in terms of the receiving the knowledge, but also problem that negative spillover as a cost push inflation. So thank you. I hope I explained. This is the last minute, and let me introduce. So I'm looking for full-funded PhD position. I will be thankful if you introduce me someone who is working CBG or international trade. Thank you. That's all.
Yeah, thank you, Onur. Very interesting paper. You tackle two issues: double counting in when there is a multi-country fragmentation of production, and also the knowledge spillover in value chains of the impact. How can they improve the trade, the technology? And so, do we have any questions from the audience, from the chat? No, you can raise your hand. Okay, if there are no questions, can I ask a quick question? From one of your last slides, you said you identified an optimal double counting of 1.54%, and it was derived based on your knowledge spillover regression.
Yes.
Did I understand correctly? So could you please clarify a bit more what you mean by optimal double counting on that slide?
Sure. So this is the sectoral linkages. We estimate this one based on each so domestic or local input-output table, or bilateral or something, etc. Multilateral integration is rely on the equation. If I go back 5.1, so this is rely on this perspective. So each domestic feedback effect, bilateral and bilateral spillover from the multilateral feedback effect. So this one is the version that we can estimate sectoral contribution. The more, like, if you increase export or final demand, etc., how this contribute to sectoral outcomes. So this is the contribution where one's product increase and how increase, so one fundamental increase, how this contributed to sectoral outcomes, right? So this is also contribute to the way the spillover between sectors. Is it not clear?
Okay. Yes,
And
I understand.
yes, this
optimal.
sure.
Yes.
Yeah. Oh, yeah. I think it's consistent with the WTO, also not the World Bank study. And then the second one is we estimate knowledge flow. So we have two different variables, and then after that we just merge. This is the from the IO table. This is from here. So we can estimate here accumulated based on the production stages. The more, so let's assume this is the second time this product export, and then the country receive, let's assume there's a productivity, from the distance or learning from different perspective, they improve their production. So based on the production process, we just multiply. So this is the traveling goods among countries regarding production stages. If we assume average value-added perspective, so let me go back again. This is average, actually, not a value-added. So this is average based on each sector. And if you multiply here, so we can get based on the value-added perspective. So we just multiplying in terms of the equation 5.2 stars. So let me go here. This is the matrix. So we focus on the domestic, domestic value-added or foreign value-added perspective. You can estimate it.
Okay, just my concern was that in the regression you were using import data from Constraint, which is not GVC related data. It's gross imports.
Right.
And in the
import flow.
The gross import flow. To estimate the impact of imports on patterns, the knowledge flows.
Right. Yeah.
And you used this estimate to multiply on what, on GVC, on GVC.
Sorry.
Yeah. So I have this question: how do you connect this coefficient derived from gross imports to this formula from Leontief inversion matrix?
First, we estimate the optimal or minimum knowledge flow coefficient, right?
Mm-hmm.
So from the pattern databases. So in terms of the pattern databases, you can depend the variable pattern, and you can put RD import or FTA based. There are a lot of different perspective calculations. So we estimated this N version. If you get the N version, and then going back to here, so this is the production stages of continuous input. If you assume product arrive Geneva, or sorry, Switzerland, and then this product export from Geneva to Switzerland to Germany, German export to other country. So we assume that there is an end stage production segment stage, right? Then the more the product travel, the more they contribute. So we are estimating optimal, or like the circle of or end of production process. I don't know how to say. This is the process we are taking into account. So this is actually the capturing the CT or something. And if you merging here with the CVG participation, you're getting here. Okay, let me go 8 point. Sorry, that's me get anyway. So this is the contribution where it's come from. So this product, in terms of the from the CVG participation, this product travel a lot within T country. T country has a T-1, etc., etc. This is continuous stage, right? This is the idea coming from the product. So this is from the domestic value added perspective. If then we just merging here is that if you extend this version again, you will just face the here. And I didn't put here to confuse people. There, in my original paper, I put this like domestic foreign value added multiply with the coefficient as well. So since I have a limited time, I didn't think that I should also present here. But yeah, the logic is logic is the endless production stages. I hope I explained maybe
yes,
not.
Yes,
Okay.
It's more clear now. Yeah.
Okay, perfect.
Thank you. And any other questions? Okay. Well, I think then if there are no questions, then excellent. I think we can wrap up our session. I would like to thank all the participants and the 4 speakers today who brought their papers with new findings, all related to supply chain. So the first paper was looking at the impact on the supply chains through this sneaky type of restriction, local content requirements, and how they create worse outcomes than tariffs for GDP and welfare. The other 2 papers looked at the electricity side and the impact of electricity infrastructure on supply chains. And the final paper contributed with theoretical expansion for multi-country GVC and knowledge spillover side, or benefit, knowledge spillover benefit for global value inside global value chains. So with this, I would like to, if there are no further comments or questions, I would like to conclude our session and wish everyone a good rest of the week.